Good afternoon.
Good afternoon.
Well, how's everybody feeling today?
Feeling good.
Are ya? Good. Well, started off kind of rough for me, but I'm gaining momentum. So, anyway, I'm glad to see you guys here today. Let's see. Looks like everyone's there at Mogyan. I can't quite see Nathan. Are you there in St. John's? How about Aiden? Okay, there's Aiden, but Joey is not there.
He's at a wrestling tournament, I think.
All right. Okay, how about Chloe? Is Chloe there?
Yeah, she's here. We just got on our side anyway.
Okay. All right. Well,
Mr. Strong,
yes, sir.
I have to leave early today.
Okay.
So just
All
so you
right.
know.
Okay. Well, let's go through the closing schedule here really quick. Just so in case you have any questions. All right. So today we're going to be working on chapter 6. So that again, that's we're not going to. The idea is just to kind of show you how to set stuff up. We're not going to be able to finish or go through it all in detail. It's just kind of like an extra credit thing. That's kind of how I see chapter 6. So if it helps your grade, great, but it won't hurt your grade. So when you take that test, remember I'm going to drop your lowest test. So even if you were to decide not to take it, or if you did poorly on it, no big deal. Now and that's actually going to be open after class today through Sunday, or through Monday, and there's no time limit on that, and you can take it at home, just not together or anything like that. The other thing that's going to be different about chapter 6 that I just decided to do is I'm going to give you, instead of your average score, I'm going to give you your highest score. So if you take it and then don't do as well as you want, then you know what ones to focus on, even more. And if you really do a good job on it, anyway, you'll get your highest score, and then I drop your lowest test. So I'm really hoping that it'll help. And plus, anyway, that's kind of how I want to treat it, where it's sort of extra credit anyway. So just do your best, and it shouldn't, and it can't hurt your grade. Okay, that's the main thing. Okay, so that's today. Then tomorrow I'm going to open up chapter 5 test during class time, and then I also during the day or during whenever to set up your quiz 5-4 through 5-6. That's just one quiz, and then whatever else you let me know. And several of you have already told me certain things that you want to make up, and anyway, and so you can work on that tomorrow. So as far as the quiz time, I have Winslow wants the 5-4 through 5-6 quiz at 9 a.m. Is everybody else, you want to do it right before class? Is that kind of the default? I don't think it's going to take you. It's not going to take you an hour or whatever. I mean, when I load up the 5-4 through 5-6 quiz, I mean, I put an hour, but you're not going to need an hour to do 5 questions. So you might consider, if there's something else that you need to make up, or just a second attempt on something, and that could be different for all of you. Just let me know. Okay. All right. And then the chapter 5 test will be during class time. And so then Thursday, we'll start the final exam during class time, part 1. And then Monday will be part 2. Friday, or just any time where if you schedule with your talent aid, you can make stuff up, or second attempt, or extra credit quizzes, or whatever you want to do. Okay.
Hey, Mr. Strong,
Yes.
for the 5.4 through 5.6 quiz, all the people in Mogollon need to take it at. Can we take it at 10?
At 10 a.m.
Yeah.
Okay. All right. So Mogollon at 10 a.m. Okay. And then St. John's, you guys will be at 1:50 to 2:50, unless you tell me otherwise. Okay. All right. That works. Okay, so let's see. I have here Sunday midnight. Let's. Should we keep it Sunday midnight, or do you want Monday midnight? It doesn't really matter to me. Does it matter to anybody? The chapter 6 take home deal?
Monday at midnight.
Okay. Okay. Now, again, no time limit on that, but yeah, you do have to be a little careful with that type of test, because depending on how you have your computer set up, if you leave it, there's some computers that when they go to sleep mode, they will automatically submit and you'll be done. So don't leave it for a long period of time. I mean, if you need to take a lunch break or something, or I mean, I'm just warning you, because based on how students have had to deal with that, and it really depends on how your computer, whatever computer you're taking it on, how it's got its settings. Okay. All right, and then remember that Monday midnight is also when the extra credit evaluation is due. Okay. So this is our last class, our last broadcast of the year, and anyway, so I kind of I'm in some ways I'm excited to get on to chapter 6. Other things I kind of just wish that we were doing something else. Well, usually the last day of the year, I kind of wish I had you guys in my classroom with me. Anyway, but I really have enjoyed this class. You guys have been great, and I will always. This has been a tough semester for me personally. Been a lot of personal things going on in my life, and I have to tell you, there were days that the only thing that was getting me through was teaching. And anyway, so I really appreciate you guys. So anyway. All right. Well, any other questions or comments before we jump back into chapter 6? Okay. So now, because this is the last, our last class face-to-face, or last broadcast, I should say, don't hesitate for a second to reach out for me. If you have a concern, or if you need a quiz or test opened, or if something happened, you guys had, I don't know, a last second fire drill during the chapter 5 test. I mean, let's hope that doesn't happen. But anyway, whatever happens, just don't hesitate to reach out for me. Okay, well, let's go on to chapter 6. And so, like I was saying yesterday, the purpose of chapter 6 is for you to see a lot of variety in setting up and evaluating the integrals. And all of the integrals that we're going to do here, you can do on the calculator. And I have to say, I was really impressed yesterday that even some of the harder integrals that you guys were able to do on the calculator. So I'm going to focus more even today on just setting up the integrals and maybe even less on the calculator stuff because you guys seem to be okay. But at any time, if you feel like you need practice, then that's great. Okay, so we had left yesterday with talking about the washer method, and so when you revolve a curve around an axis where you have a gap between whatever area and whatever line that you're revolving around, that gap is going to produce cross sections that will be not circles but washers is what we call them, where it's like they have a hole in the middle. So when that happens, the formula for the area is the area of the big circle minus the area of the little circle. And so we call it pi. Capital R squared is the big radius. Little r squared is the little radius, well, little r. And so if you factor out a pi, then it's pi times big R squared minus little r squared. And so then when we integrate the area, that's how we get the volume. Okay? So let's look at this one. It says the region bounded by the curve y equals x squared plus 2. So this parabola here. And the line y equals negative x plus 4. So the line here is revolved around the x-axis. So I like to draw the little rectangle. And so you imagine if you revolve around that x-axis here, there's a gap. So the cross section is going to be a washer. Is when you revolve that, is there's a hole in the middle. So to find the big R is going to be the top function. The little r is going to be the bottom function. So when you set up your integral, it's going to be pi times, okay, so big R, the top function is the line. So negative x plus 4 squared plus the little function, or the lower function, that's the parabola, x squared plus 2 squared. And so you subtract that. Now, it doesn't really tell us these limits of integration, negative 2 to 1. And so if you're not told what those are, how do you get them? How do you know you're integrating from negative 2 to 1? There's nowhere in the problem that suggests that.
Negative 2 and 1 is where the line intersects the parabola.
Yes. So the points of intersection. So second calc intersect gives you those. And so if you have vertical rectangles, then it's your x values that you're looking for. So negative 2 to 1. Okay? All right, so do you want to put those in, or do you put this in, see if you got it, or do you think you want to try putting that in?
Yeah.
Or do you think you got it? You do? Okay. All right, let's put that in the calculator. Make sure you feel good about the answer there. All right, so Skylar, when you've got it.
I got 101.7. Did you forget to multiply it by pi?
Probably.
Oh,
Yes.
I don't even have this one.
What did you get multiplied by 5?
101.
So is everyone getting 101 pi?
I am.
Yeah?
What was your one?
Does anyone want me to work it out? Put it in? All right, well, I'll just trust you. So 101 pi. Now, you could multiply that out if you wanted to. It doesn't. It's all good. Okay? All right.
Mr. Strong, it's
Yes,
not
please.
101 pi, it's 101.788.
Okay, thank you. All right, there we feel better about that. Thank you.
Mr. Strong, that's after you multiplied the pi, so the pi shouldn't be there. If
So the final answer is 101.788?
yes.
Okay. All right, so does anyone disagree with that? Okay. All right, well, I'll trust you.
Stuck at France.
All right, so the next one, finding a volume using shells. Okay, in the disc or washer method, the cross sections, or like the little rectangles, that's what we're calling the cross sections, are perpendicular to the axis of rotation. In the shell method, they are parallel. So it's kind of like this. If you have, so let's say you have some curve. See, we draw the little cross section, and see then when you rotate it around the x-axis, see, it makes like a little disc because it's perpendicular to the axis of rotation. Okay? In the shell method, see, let's say you're trying to find this area and you're rotating it around, let's say, the y-axis. Well, then your rectangles are going to be parallel. So instead of making like a circle or a disc, they make a shell. And kind of the way that I visualize this is, it's kind of if you've ever like made homemade candy or whatever, you dip it in like chocolate. And so you create this shell around it. And so the shell method, it's like we're adding up all of the different shells. Okay? Okay, so the formula for the shell method, okay, well, let's see, the region enclosed by the graph of y equals 4x minus x squared and the x-axis is revolved around the vertical line x equals -1 to form a solid. So this is draw a picture with a horizontal and then a vertical cross section.
What is this? Parallel and perpendicular and parallel.
So here's the idea. So here's the graph, and then I drew a let's see, with a horizontal and then a vertical. Okay, so with a horizontal shell, and we'll move this one out of the way. So with a horizontal cross section, see, actually, you can't do it with a horizontal rectangle. Okay, why? Because see, when you're trying to find the width of this rectangle or the length, I guess, normally you would subtract one function from the other, but this is the same function. So you're not going to be able to find this right here, this distance of the length of the rectangle. You can't do it. So then what you have to do is change your rectangles here to vertical rectangles. And so now the height of the rectangle is just the function. Okay? The function. But now when you're rotating it around this line, okay, then it's going to create these shells. And so the formula for the shell method is 2 pi RH. So when we're talking about the R and the H, we're talking about the shell radius and the shell height. So 2 pi RH, that's like the, well, that's the formula. Okay? All right, so how do we get that? Well, we have 2 pi. So the shell's radius is the radius from the axis of rotation. So this is an x value, and this is 1. Well, how to get 1? Well, because it's rotating around x equals -1. So you take that distance, 1, plus whatever the x value is, and so x plus 1 is the shell's radius for any x. Okay, the shell height is going to be the function. So 4x minus x squared, that's the shell height. And then the limits of integration are, well, see, you're adding up all these vertical rectangles underneath the curve. So it would be from x equals 0 to x equals 4. So those would be the limits of integration. All right. So, so the thing now, this one there's no r squared or in it. It's just 2 pi RH. Okay. All right. Any questions on that one?
How do you find the radius again?
Okay. So the radius is the distance from the axis of rotation to your rectangle, your vertical rectangle. Okay? So if it's just the y-axis that you're revolving around, then it's just x. That distance is just whatever the x value is. And then, but since the axis of rotation was to the left, 1 unit, you have to add the x plus 1. So that's how I got x plus 1. So let's say the axis of rotation was at x equals +1. Then that distance, well, we'd have to use a completely different setup for that. So I'm not going to do that. All right. Any other questions on that? All right, so let's go.
This is actually really confusing to me.
I'm sorry. It part of it is that it's just, I'm trying to throw all these formulas at you, okay, and go through them, and I understand. Let's keep going though, and hopefully you'll kind of get the idea of using these formulas a little bit. So, okay, so the next one is arc length. So the formula for the arc length, there's actually 2 ways that you can write it. So it's the integral from a to b of the square root of 1 plus the derivative squared. So if you write the derivative as dy dx, then write this one. If you prefer to write the derivative as f prime, then write this one. Okay? But they mean the same thing. So what that is that, like, if you were to draw a curve or whatever, if you could straighten it out and measure the length of it, that's what this is. That's what this gives you, is the actual arc length. Okay? So this says find the length of the curve y equals x to the 3/2 from 0 to 5. Okay? All right, so in order to use this formula, you need to have the derivative. So what is y prime? What would be the derivative here?
It would be 3/2 x to 5/2.
No, you're doing the antiderivative. With the derivative, you do bring the 3/2 in front, but then you lower the exponent by 1. So it'd be 3/2 x to the 1/2. Okay? So that's the derivative. All right, so now if you plug that into the formula, then, see, these are our limits of integration. So it's kind of nice because usually you don't have to figure those out. It's just going to be the integral from 0 to 5. And then it's the square root of 1 plus. Okay, so notice for the derivative, then I went ahead and squared it. So if I square 3/2, I get 9/4, and then x to the 1/2 squared is just x. So this is the square root of 1 plus the derivative squared from 0 to 5. All right, so go ahead and put that in. Let's see what the answer is there. All right, so Denon, when you've got it.
$12.407.
There you go. Good job. Any questions on that one? Now, I like those because you don't have to be a great artist like on some of those volume ones. Okay? All right, now, the next one is surface area about the x-axis. All right, so this has the arc length formula in it. Okay, so the surface area is 2 pi, and then the function, the y value, or f of x, times the arc length. So it's kind of like the arc length is like, if that's your dx, then you multiply by the the height 2 pi y, and you're getting the arc length times 2 pi y, or 2 pi times the function. So again, this arc length, the square root of 1 plus the derivative squared. So you do that part the same, find the arc length, and then you multiply by 2 pi y, and that gets your surface area. So again, you don't have to write down both of these formulas, just one of them. However you want to write the derivative squared. All right. All right, so it says find the area of the surface, so the surface area generated by revolving the curve y equals the square root of x from 1 to 9 about the x-axis. Okay, so we start off with the derivative. Well, actually, you could start off rewriting the function as y equals x to the 1/2. So then the derivative, you bring the 1/2 in front, and then it's x to 1 lower power. So that's x to the negative 1/2. So then when we square that, well, you square 1 and you get 1. You square 2 and you get 4. You square radical x and you just get x. So that's the derivative squared. All right. So now when we set up the integral, it's going to be the integral from 1 to 9 of 2 pi times the function, square root of x, times 1, the square root of 1 plus the derivative squared. All right, any questions on the setup? All right, so this one's a little tricky with the fraction underneath the radical, so let's definitely have you try putting that in the calculator, making sure that you can get that. Okay. All right, so David, when you've got it.
I got 117.32.
Okay. So let's see, 117. Did you round this when you multiplied by pi?
No, I think I figured it out. I didn't put the right intervals.
Okay.
Yeah, I didn't put the right intervals.
Okay. All right. Any other questions on that?
I got 100. Skylar and I both got 167.394, and I think I'm not sure if we did it wrong or if that on the board is different, but I think he did 1 plus 1 and then like divided by 4x instead of making it the fraction. Or
Okay. So yeah. So this is yeah. So it would do the division first. So it would do 1 plus and then 1 divided by 4x. That part is correct. So what did you have underneath the radical? In your
I
calculus?
put 1 plus parentheses and then the rest.
So you
So I just
had
put parentheses before it.
so you had the square root of 1 plus parentheses 1 divided by. Oh, did you have parentheses around the 4x? Or did
It's
you
not.
have?
It's not letting me go back. Sorry.
See,
Did you put this one before?
the reason why I say that is because the x is in the denominator, you actually have to have an extra set of parentheses around the 4x.
Oh, okay. Yep.
Otherwise, it's just dividing by 4 and then multiplying by x.
Okay. Sorry about that. Thank you.
No, I'm so glad you said something because that's what we're trying to do is to make all the mistakes now. Okay. All right. Any other questions? Okay. All right. So if you revolve a curve around the y-axis, it's pretty much the same thing, only your derivative, everything is going to be in terms of y's instead of x's. So it's still 2 pi, and then your x, it's x equals in terms of y. So it's a little misleading because these are functions now that will be in terms of y. So it's just like y equals in terms of x. So this is x in the derivative, x prime. Well, you'll have y's in your problem here. But it's really the same, it's the same formula. It's just that when you revolve around the y-axis, then all your equations have to be solved for x in terms of y. So you'll have like x equals y squared plus 3 or something like that. Okay. So let's, so to do one of those examples, so it says the line segment 2, x equals 2 minus y, and the limits of integration are in terms of y here. Is revolved around the x-axis to generate a cone, find its lateral surface area. So what we've been doing is finding the lateral surface area, but we're finding the surface area generated by the curve. So not the area of the bottom here. Okay. So we set it up the same way by first taking the derivative. So x equals 2 minus y, so x prime, the derivative would be -1. So then the derivative squared is going to be -1 squared. So we're going to have the integral from 0 to 2 pi times x, what the function solve for x, so 2 minus y goes here, and then the square root of 1 plus the derivative squared, so -1 squared. Oh, All right, so go ahead and plug that in. All right, so Hannah Z.
I got 17.77.
All right, good. Any questions on that one? Okay. All right, so work and fluid forces. The work in general, let's see. No, let's wait. Let's wait on that. All right, let's just do the second part. The work done by a variable force, because that's the one that requires calculus. So the work done by a variable force along the x-axis from x equals a to b is the integral of the force. So if you have a force and you move an object, you push an object 5 feet or whatever, that's the distance. So the integral of the force as the object is being moved from point A to point B, that the integral of the force is the work. Okay. So it says find the work done by a force of F equals 1 over x to the third newtons along the x-axis from x equals 1 meter to x equals 5 meters. Okay. So then you just integrate from 1 to 5 the force. So 1 over x to the third dx. And so you can either put it in the calculator like that, or you can put it in there with a negative exponent, whichever you prefer. All right, so go ahead and try that. All right, so Rachel.
.48.
0.48. So that's 12/25ths or 0.48. And the units for work are in joules. So capital J in joules. Okay, so all right, well, we're down to 3 minutes. So I think we're gonna just stop right there. So again, what I've tried to do with this sheet is sort of organize, kind of help you come up with a place to put all your like making a formula sheet. But, you're certainly welcome, because it's open book. You're welcome to, as you go through the test and it's not timed, then, you can look up problems and examples that are very similar, how that goes. So, anyway, so that's the best we're going to be able to do for chapter 6. So, anyway, all right. So, does anyone have any questions on what we're doing here the rest of this week? Okay, so please communicate with me if you have any concerns or issues that I can help with. Then just know that, so Tuesday, I'm going to be coming in and working on your final exam. We'll do a final curve, and it will be based on not only this class, but my morning class, the highest grade. I calculate the curve. I will also add in the extra credit from the essay. And then, so you might see your grade change on Monday. And Joran, I told you, I did tell you I fixed that extra credit thing. Somehow the extra credit for the survey was adding points to the final exam. And since we didn't have a final exam, it would averaged in over 100 for the final exam for her when she did that. So that was pretty funny. So anyway, all right. Well, you guys, good luck, work hard, and let me know if you have any other issues. Otherwise, you won't see me until January. So hopefully you'll all get new cars for Christmas. No, I don't really hope that, but I hope you have a good Christmas and a good luck on the final. So you guys have been great, and we'll see you.
Thank you. Have good holidays.
Thank you.
Bye, Mr.